For any planning and developmental activity, the formulation of an appropriate watershed framework is prerequisite. Such framework follow a hierarchical system of delineating hydrological units and their integration into watershed as a unique individual entity with clear identifiable hierarchical lineage as basin, catchment, subcatchment, etc. Since the drainage system developed and evolved through competing interaction of gradational, which is erosional and depositional processes, between geological substrate and exogenic forcing by climatic factor like precipitation. Therefore, a drainage basin represents the outcome of fluvial geomorphic processes, natural and anthropogenic, over a prolonged period. The quantitative description of drainage network in a given landscape is defined by morphometric analysis. The parameter also indicate stages of geomorphic evolution of any area. The morphometric method started evolving in mid-19th century and processes amplified with the advent of personal computing and availability of digital data, especially the digital elevation models DEM. The morphometric examination of a basin is achieved through the computation of linear, aerial, relief, and gradient of a channel network in a basin or watershed. This table provides detail of the methodology followed for the computation of commonly used morphometric parameters for basin analysis or watershed analysis. We will briefly discuss some of the important morphometric parameters of a watershed. Learners, linear aspect of the watershed include the following parameters. The basin unit of a drainage is its order. The drainage network is classified in a hierarchical system defined by stream ordering, where the first order is the incipient stream at its point of origin. Two first order segments join to form a second order, and two second order joins to form third order stream, and so on. The stream order indicate the scale of drainage catchment. The total order-wise stream segment in a given drainage basin is known as stream number. It is the number of stream segments of each order demonstrate an inverse geometric sequence with their respective stream order, which means the higher order stream will have lower number in a catchment or watershed. The stream length is estimated by the summation of channel segment for each order. Typically, the total length of a stream segment is decreasing with the increasing stream order. According to Horton's law, the mean stream length of each order display a geometrical similarity with the stream order. Stream length ratio for a stream order is defined as a ratio of the mean stream length of a given order with the mean stream length of the previous order. The variation in the stream length ratio shows major change in hydrological characteristic. Ideally, the stream length ratio for a given basin is constant. Changes in stream length ratio from one order to another order indicate their different geomorphic stages. The bifurcation ratio for a given order is a ratio of the number of stream segment of the order, that is its stream number, to the number of stream segment in the next higher order. Generally, the bifurcation ratio shows variation from one order to the next order, which may indicate the variation in the geological development of the basin. The lower values of the bifurcation ratios are characteristic of a drainage basin which suffered less structural disturbances. The bifurcation ratio shows variation among the stream order, which may be because of the variability in the lithology. Rho coefficient is computed by taking the ratio between the stream length ratio and the bifurcation ratio. It is an important index that relates drainage density to the physiographic development of a drainage basin. It enables the characterization of storage capacity of drainage network, thus a metric for indicating the highest degree of drainage development in a given basin. This metric depends on geological, morphological, climatic, biological, and anthropogenic factors. Learners, aerial aspect of morphological study of drainage basin include describing the arrangement of aerial element like the size and dimension of the watershed that indicate basin geometry. It includes the area of drainage basin, which is determined by the extracting the drainage basin using a pour point. It is used to determine the various relationship with total stream length parameter length of the basin. Basin perimeter is outer circumference that encloses the basin area. Basin perimeter helps in determining the size and shape of the basin. The form factor is a ratio of basin area to the square of the basin length. For a perfectly circular basin, the form factor would always be less than 0.754. A smaller value indicates a more elongated basin. The basin with high form factor demonstrate high peak flow for a shorter duration, whereas the basin with low form factor has a longer to moderate flow duration. The concept of drainage frequency is the number of stream segments of all orders per unit area. The lowest stream frequency indicates that the basin has permeable surface material and low relief. The drainage density is estimated by dividing the total stream length of all order by the basin area. Drainage density is a quantitative measurement to evaluate the dissection of landscape and depends on the permeability of subsurface material, vegetation type, and relief. Low drainage density indicates a highly permeable subsurface where the land is covered with dense vegetation and relief is low, whereas a higher drainage density indicates less permeable or impermeable surface, sparse vegetation, and high relief. Drainage texture can be defined as a ratio of the total number of the stream to the basin perimeter. It is an important parameter where the relative spacing of drainage lines are evaluated and highlights the infiltration capacity of the basin. The drainage texture can be classified into 5 groups: very coarse, coarse, moderate, fine, and very fine. The elongation ratio is calculated as the ratio of the diameter of a circle of the same area to the maximum basin length. The elongation ratio value ranges between 0.6 and 1 for a basin from a different climate and geological setting. The elongation ratio can be grouped into 4 categories: circular, oval, less elongated, and more elongated. The basin of circular shape indicate more efficient runoff discharge over an elongated basin. Circulatory ratio is a dimensionless ratio defined as the ratio of basin area to the area of a circle having same perimeter as the basin perimeter. The circulatory ratio varies from 0 to 1. As the basin shape tends towards a circle, the circulatory ratio tends to unity. The basin with circulatory ratio ranges from 0.4 to 0.5 indicate elongated and highly permeable homogeneous geological formation. The compactness coefficient of a watershed is defined as the ratio of the perimeter of a watershed to the circumference of the circular area having the same value as basin area. It depends on the slope of the basin while independent of the basin size. The infiltration number is estimated by multiplying the drainage density and stream frequency of a basin. It gives an idea of the infiltration characteristic of drainage basin. The infiltration number is inversely related to infiltration. For example, the higher the infiltration number, lower the infiltration capacity, and vice versa. Length of overland flow is referred to the length of the runoff of rainwater on the surface before it forms a definite channel. It generally depends on the slope length of ridge and land cover condition. For the convenience of computation, the length of overland flow is determined by taking reciprocal of half of the drainage density. The length of overland flow is an important independent metric affecting the physiographic and hydrological development of the basin. Dear learners, relief aspect of a watershed give three-dimensional perspective. It includes total basin relief, which is a difference between the highest elevation, which is the source of the principal channel, and the lowest elevation or basin outlet. Relief ratio is computed as the ratio of the total basin relief to the distance over which the relief was measured. The relief ratio defines the channel gradient and overall steepness of the basin, which correlate with the hydrological characteristic and intensity of erosion process of the basin. Hilly region is characterized by high relief. Relative relief, also known as local relief or amplitude of available relief, is expressed as the difference between the highest elevation and the lowest elevation in a unit area. Relative relief is computed using following formula. Gradient ratio is determined by taking a ratio of total basin relief to the basin length. The ruggedness number is a dimensionless parameter calculated as a product of the basin relief and the drainage density. It is also expression of slope steepness with its length. Many river basins face tectonic forcing. Hence, the asymmetric factor of drainage basin is a way to evaluate the effect of landscape tilting due to tectonic activity.